Okay, so in this video, what we're going to attempt to do is to kind of put everything together. Our goal for this video is to take an expression that is a quadratic trinomial written in standard form and rewrite that as a product of linear binomial factors. The technique that we're going to use to do this is called the Xbox method or the area model method. Now, this method relies on the information that we discovered in the previous video, and you can see that that's written up at the top of the screen here. And I'm going to be referencing this as we work our way through this video. So let's get started. So we're going to take x squared plus 3x plus 2, and we're going to try to rewrite that as a product of linear binomial factors. So here is the first step in the process. The first thing that we're going to do is we're going to multiply the constant term and the quadratic term. And what I'm going to do is to keep my work organized, I'm going to draw this little x here. So the product of 2 and x squared is 2x squared. So let me make a note for you that this number right here is the product of constant and quadratic terms. All right, I'm going to explain to you why you need to do this as we kind of work our way through. Now, what we're looking for are factors of 2x squared, so factors of that product that add up to the middle term. So this term right down here that I wrote is the middle linear term. All right, so in this case, for ours, it's 3x. That's the middle linear term. Now, what we're going to be looking for, as I had mentioned, are factors of 2x squared that add up to 3x. And if you remember back to the last video, all right, you see this middle term, ax plus bx. Those come from ab times x squared. This is what we talked about in the previous video. So let's think about some factors of 2x squared. So factors of 2x squared. So we have 2x times x. If we multiply 2x times x, we get 2x squared. And the sum is 3x. So that actually works out nicely. There are other factors of 2x squared, so negative 2x times negative x. If we multiply those together, we get positive 2x squared. But in this case, the sum of those is negative 3x. So in this case, the numbers that we're looking for are 2x and x. So 2x goes here and x goes here. Now these numbers, these middle numbers, are factors of 2x squared that sum to the middle term. Okay? So now that we've got that set up, what we're going to do is we're going to set up our box. Now, the box that we're going to use is going to look just like this up here. Okay, so I'm highlighting it in green right now. So let's do this. So I'm going to set up the box. This is the area model part. And here's how we're going to set this up. Now, that box up there is set up in 4 pieces. And if you look, this right here is the first term in our original quadratic expression. So the first term for number 1 is just x squared. So I'm going to pop that in the top left-hand corner. The bottom right hand expression, okay, in the bottom right-hand corner is the constant term a times b. So if we go back to our quadratic, that's 2 rather. And then the other two spaces are the two terms that are factors of abx squared that add up to the middle term. That's these numbers right here that I'm circling. So they go here and here. All right, so if you look, what we have is basically the opposite of what we did last time. So last time we started off with the factors and got the area. Now we have the area and we want to find the factors. So the way that we're going to do this is we need to find the GCF of each column and row. So let's go ahead and do that. So let's do the first row. The GCF of x squared and x is just x. The GCF of 2x and 2 is 2. The GCF of x squared and 2x is x. And the greatest common factor of x and 2 is just 1. So this tells us that x squared plus 3x plus 2, which is our original quadratic trinomial, in factored form should be x plus 1 times x plus 2. And if we FOIL that out, x times x is x squared, x times 2 is 2x, 1 times x is x, so if we add those together we get 3x, and then 1 times 2 is 2, so that is indeed correct. Now what I'm going to do is I'm going to move through the next few a little bit faster. All right. So here we go. So I'm going to draw an X to keep us organized. Okay. And the first step that I'm going to do is I'm going to multiply the constant term and the quadratic term. That gives us negative 15x squared. I'm going to put that right up there to keep us organized. Next, we're going to put the middle term below that. So this is your middle linear term. Now what I'm looking for are factors of negative 15x squared that add up to 2x. So I'm thinking about factors of 15. So I've got, say, 5x and 3x. But if I add those together, I get 8x. And if I multiply them together, I get positive 15x, not negative 15x squared. So one of those two factors has to be negative in order to make this work. So if the middle term is positive, that means this smaller number is going to have to be negative. So 5x times negative 3x is negative 15x squared. 5x plus negative 3x is positive 2x. We're good. Okay, so now we're going to move over, to our area model portion of the Xbox method. So again, if we remember from above, the top left-hand corner of our area model is the first term of our quadratic, so that's x squared. The bottom right-hand corner is the constant term. And then the other missing two boxes are these factors of negative 15x squared that add up to 2x. Doesn't matter where they go, just as long as they end up in one of those two boxes. So again, now we're factoring GCFs of columns and rows. So GCF of this one is x squared. I'm sorry, just x. GCF of this row looks like it's negative 3, because negative 3x and negative 15 are both divisible by negative 3. This column looks like that's x, and then this column, the last column, 5x and negative 15 are both divisible by positive 5. So x squared plus 2x minus 15 is equal to, it looks like x plus 5 times x minus 3. Okay, we'll do 2 more real quickly, and then I'm actually going to do 4 more in the next video. So let's do this next one. So again, picking up the pace a little bit, multiply the first term and the last term together, so the constant term and the quadratic, and that gives us a product of 20x squared. And now we need the middle linear term down here. So we're looking for factors of 20x squared that add up to negative 9x. So in this case, some factors of 20x squared would be 20x and x, could be 10x and 2x, could be 5x and 4x, but they have to add up to a negative number. The factors have to add up to a negative number. So in this case, I'm going to take negative 5x and negative 4x. If we multiply those two numbers together, we get positive 20x squared. If we add them together, we get negative 9x. So these are the two numbers that we want. So negative 5x and negative 4x. So again, I'm going to make my area diagram. So the quadratic term from the original expression goes up in the top left-hand corner. The constant term from the original expression goes in the bottom right. And then the two factors of 20x squared that add up to negative 9x, those linear terms go here. All right, now this one is a little bit tricky, and these ones you need to really pay attention to when the middle term's negative and the constant term is positive. So again, I'm going to start factoring out GCFs. So here, that should be an x. Here, negative 5x and 20 are both divisible by 5. Then here, we have x, and then this last column, 4x and 20 are both divisible by 4. Now the only issue here is if we write this as x plus 5 times x plus 4, that middle term is going to end up being positive. All the terms are going to end up being positive. But in this case, our middle term is negative. So what we have to do in order to make this work, so x squared minus 9x plus 20, is make both of our constant terms negative. So x minus 4 and x minus 5. All right, and again, if we were to multiply this out, x times x is x squared. X times negative 5 is negative 5x. Negative 4 times x is negative 4x. And negative 4 times negative 5 is positive 20. And this is why we have to make both of those constant terms negative, to make the middle term negative and the constant term positive. All right, one last example. I'm going to erase this part just so we have some room. Now, this one's a little bit different than the others because if you notice, the leading coefficient is a number that's not equal to 1, but that's all right. This method's still going to work just fine. So, multiply the first term, so the quadratic term, and the constant term. That gives us negative 15x squared. And then the middle linear term is going to go right here, so positive 2x. So we're looking for factors of negative 15x squared that add up to 2x. And in fact, I think we did this earlier. So we should get 5x and negative 3 negative 3x. So if we multiply those together, we get negative 15x squared. We add those together, we get positive 2x. So those linear terms are going to go right here. So now we'll set up our area diagram. So again, top left-hand corner of our area diagram is the quadratic term from our original expression. Bottom left-hand corner is negative 3, which is the constant term, and then the missing two boxes are these values right here, so 5x and negative 3x. So now GCFs of our rows and our columns. So here, no GCF amongst the the constant coefficients. So it looks like x is our only common factor. Down here, it looks like positive 1. Here, 5 and 5 are shared, and then x, and then it looks like negative 3 is the GCF of that last column. So 5x squared plus 2x minus 3 is going to factor to 5x minus 3 times x plus 1. We're going to go through some more examples of this. I hope that this video was helpful. You're also going to do a bunch of practice on this as well. Thank you, and we'll see you on the next one.